Good morning, everybody. I hope you're doing well and are looking forward to a nice E-Day here today. Look, we are switching things up a little bit. We have to be done practicing. We got to get rolling. I didn't want to start the unit with a video lesson, but here we are. So this is super important. So the way this is going to work is there's going to be a video lesson today. This is going to be, I don't know, 20 minutes or so. Um, and this is all you got to do. I'm not going to ask you to do the homework assignment. I'm going to have you do the homework assignment in class. However, I will be checking to make sure you took the notes. It is hugely important, and you can't come in tomorrow having absolutely no clue what to do. This is a very simple concept, and we're going to practice it tomorrow together so you can ask me what questions you have, but you can't come in and just expect me to reteach the lesson. That's not how this is going to go. So this is hugely important. For those of you who didn't do the assignment the other day, that's not going to fly this time. So make sure you watch this video in its entirety. This is one of the more important concepts we cover all year. So we are actually skipping 10.1 for now. We may or may not come back to it depending on timing. And we are jumping straight to 10.2, which is really the meat and the basis for this chapter. We are solving equations by factoring. Oh my goodness. We're just adding a little more to the equation here. You know what I mean? So we're talking about polynomial equations. We've been solving polynomial equations this whole time, right? We solve linear equations for breakfast, lunch, and dinner, right? That's what we've been doing basically all year, right? You just got a plain old X in there. We can do these all day, right? Now what we're going to be talking about is solving quadratic equations for the most part. And you might see the occasional cubic equation, but quadratic equations are definitely going to be our bread and butter in this chapter. And for all of you who so kindly asked, why in the world would we ever need to factor, Mr. Kaplan? Well, here is your answer. We factor because, or really one of the main reasons we factor is because it is our primary way for solving quadratic equations, okay? So let's scooch on down here. We're talking about this thing called the zero product property. And some of you are going to look at this and be like, well, that makes zero sense. But I'm going to do my best to explain it here. The idea is, here's the words. It says if the product of two factors is zero, then at least one of the factors must be zero. Okay, and then you got some math over here. If a times b equals zero, then either a equals zero, b equals zero, or both a and b equals zero. So let me kind of break this down for you. If you've got, like it says here, a times b equals zero. Basically what this is saying is, well, for something that equals zero, think about it. Let's say a is 3, right? And we know this equals zero. What does b have to be? Well, b has to be zero, right? Both of them don't have to be zero. They could, but only one of them has to be zero. The same applies vice versa. Let's say b is 3. Well, then in order for this to equal zero, a would have to equal zero. Okay, so that's this idea of the zero product property is they don't both have to equal zero, but one or the other does. And so that's kind of the basis for all this. So here are the steps that we're going to follow in order to solve something by factoring. Okay, start by setting it equal to 0 and getting it in standard form, right? What I mean by standard form, notice in these guys up here, right, your largest degree term comes first, so x squared, then x, then your guy without an x, or if you're looking at a cubic, it's x cubed, then x squared, then x, then no x, right? So that's what I mean by standard form. It is set equal to 0, your terms are on the same side, and they're in order from greatest degree to least degree. Okay, then you're going to factor by any method, right? You're always still going to look for a GCF first. This is exactly what we did last chapter. GCF first, then either grouping if you've got 4 terms, the box game or T-chart, whatever you decide to do now for 3 terms, or difference of squares for 2 terms. But you're going to factor it by any method. Last but not least, you're going to set each of your factors equal to 0 and solve those equations. Okay, so let's see how this looks. The nice thing, so we're actually starting with some nice ones here. These first two, steps 1 and 2, are done. And hopefully this looks like something that's been pre-factored, but notice they're both set equal to 0, right? And this is not something we would continue factoring, right? These are both essentially pre-factored. This guy here looks like something that you pulled a GCF out of. This guy here looks like something that you maybe pulled a GCF out of, and then some, but these are pre-factored terms. So steps 1 and 2 are done. The goal of these first 2 examples is not to actually factor anything, but just to show you what you do once you have something that is factored. So we're jumping straight to step 3. And basically what this says is you take each factor, right, GCF included, and you set it equal to 0. So in this case, we're going to have 3n equals 0. We're also going to have n plus 2 equals 0. Okay, 3n equals 0 and n plus 2 equals 0. And that's basically what you solve, right? Basically, you're saying, look, the idea of factoring is this is multiplication. And what we just said is one of these two things has to equal 0 for this to work. So we're saying either this 3n piece of this here has to equal 0, or this n plus 2 piece here equals 0, right? It's got to be one or the other. So we set them both up, and we're going to solve them both and see which potential solutions work. So for this first one, 3n equals 0. All you do is divide by 3. And so help me if you say that's undefined. I'm going to flip out. It's been on every test since we started here, right? 0 divided by anything is not undefined. It is 0. So n equals 0, right? Almost always, if you've got a variable in your GCF, that's going to give you a solution of 0. So something good to kind of keep in mind. N plus 2 equals 0. We subtract 2 from both sides, and you get that n equals negative 2, right? So notice you get 2 solutions, right? And so this is something to keep in mind here. If in a linear equation, you've got x to the first power, you generally get 1 solution, right? And that's something we're going to start to experience here. In a quadratic equation, you've got x squared, or essentially you've got 2 x's. Well, that means if you've got 2 x's, you could get 2 solutions. Okay. In a cubic equation where you've got an x cubed or essentially 3 x's, how many solutions do you think you get? You can get potentially 3 solutions. Okay, and so on and so forth. So this is something to keep in mind when you're solving a quadratic equation like we're going to be working on here. You can get potentially 2 solutions. You don't always have to. You could just get 1, but you have the possibility of getting 2 solutions. Okay, so here we go. Now, how we write these solutions now, since we're going to start getting multiple solutions instead of just writing n equals 0 and negative 2, which is fine. I want to introduce you to something called solution set notation. And basically, you put these fancy little butterfly brackets. If you're terrible at drawing them, that's okay. So am I, but give me some effort, right? And you want to just list your solutions from least to greatest. So negative 2 would be the smaller number here, followed by 0. And this is your answer. These are your 2 solutions. Okay. Next one here, right? Essentially, we've got, well, here we've got x. So basically, x equals 0. Or 4x plus 2 equals 0, or 3x minus 7 equals 0. Don't worry about the fact that that's squared quite yet. We'll talk about that here in just a second. Well, look at this. This one's already solved for us, so this one's good to go. 4x plus 2 equals 0. We would subtract the 2. Okay, we get 4x equals negative 2. And then we would divide by 4 to get that x equals negative 2 over 4 is negative 1/2. Okay, now that one's good. Next one, we'd add 7. So we get 3x equals 7. And then we divide by 3 to get x equals 7/3. Okay, and there you go. Those are your 3 solutions. Now, the only thing I want to draw your attention to, the fact that this is a 3x minus 7 squared, picture for me, if you will. Essentially, what that means is you could rewrite this out if you want as x times 4x plus 2 times 3x minus 7 times 3x minus 7 equals 0. Okay, basically what that means is this 3x minus 7 you have twice. Now you don't need to solve, oopsie, hello. You don't need to solve it twice, right? You don't need to solve it twice. You'd get the same thing each time, but you basically have 2 of the same solution. Okay, so this 7/3 is what we call a double solution, or what we'll talk about a new word for the solution here is a root. So this is what we call a double root. Okay, and what I'll ask is, this is going to be kind of rare, but I just ask that you indicate it somehow. So if we're listing these from least to greatest, negative 1/2 is our smallest, followed by 0, followed by that 7/3, and you can just kind of put parentheses out back and put d.r for double root out back. And as you can see, like I said, I am no better at the butterfly brackets than you are. Just give me some effort. And there you go. Notice we got 1, 2, 3, technically 4 solutions this time. And that makes sense because if you count up your x's, well, you've got 1x, 2 x's. And then if this is x squared, that's 3x minus 7, 3x minus 7. So really, you've got 2 more x's for a total of 4. So it makes sense that you get essentially 4 solutions. How about that? Okay. So that's the basis here, right? Essentially, you take each of your factors and you set them equal to 0. So let's do some problems where we do all these steps here. So again, steps are step 1, set it equal to 0 and get it in standard form. Step 2, factor. Those are the 2 that we didn't have to do for this one. Steps 3 and 4 are what we just did, right? So we set each factor equal to 0, and then we solve. Yes, you will get multiple answers, and that is okay. Here we go. right? We got 6 more examples. So this first one, step 1, is it set equal to 0 and in standard form? Yes, our t squared comes first, followed by our t, and it's set equal to 0. So step 1, check. Step 2, let's factor it. Well, always look for a GCF first. Always look for a GCF first. And I would even say, because this is a negative 16 here, whatever our GCF is, let's pull out a negative. It's going to make this look a little bit prettier here. But if I'm looking at this, between the 16 and the 20, I can pull out a 4. Again, I'm going to make that a negative 4. And between t squared and t, I can pull out a t. So I'm pulling out 4t, not to be confused with the number 40. That would be incorrect. So don't do that. 4t, the variable, and then what's going to be left? Well, negative 16t squared divided by negative 4t is going to be positive 4t. And 20t divided by negative 4t is going to be negative 5. So we're left with 4t minus 5 equals 0. So there we go. Always double check, could we factor this anymore? Well, this is not a difference of 2 squares situation. 4t is not a perfect square, nor is 5. So we're done factoring, and that's okay. Once we've factored it, we now want to say, okay, well, we're basically setting each of these equal to 0. Negative 4t equals 0, or 4t minus 5 equals 0. These are the equations that we now need to solve. Again, when you got that GCF with a variable, divide by that negative 4. No matter how you cut it, you should get 0, not undefined. Okay? On this one, add the 5. You get 4t equals 5. Divide by 4. And you get t is 5 over 4. Okay? And you can't simplify that. So which one's smaller? That's where we start. 0 is smaller than positive 5/4. So we go 0, 5/4. Done. And there you go. That's the gist of it. Set it equal to 0 if it's not already. Factor it. Solve each of your factors if you set them equal to 0. Done and done. Okay. Moving on to this next one. Okay. Well, look, again, step 1 is good. We are set equal to 0. It is in standard form. We're good to go. So set it equal to 0. Check. Now we're going to factor it. Well, there's no GCF amongst all of them, right? 16 and 8, 6 and 3. There's nothing that goes into all 4 of those, and they don't all share an x. So we can't pull out an overall GCF. But if I'm counting terms, we got 1, 2, 3, 4 terms, and that is my cue to use factor by grouping. So from these first 2 terms, I'm going to pull out an 8x, and that's going to leave me with, well, 16x squared divided by 8x is going to be, let me actually write this below it here. I should have done this on the previous one too. My apologies. Come on, OneNote. There we go. So we're taking out an 8x. So 8x, 16x squared divided by 8x is going to leave me with 2x. And 8x divided by 8x is going to leave me with plus 1. From these next 2, I needed to match the 2x plus 1. So I could just pull out a 3, but if I want those to be positive, I need to pull out a negative 3. So minus 3, and look at that. That's going to leave me with 6x divided by negative 3 is 2x. And negative 3 divided by negative 3 is positive 1. Okay, so there we go. That is our first step in grouping, which means this now factors to 2x plus 1. And then our leftovers is going to be 8x minus 3 equals 0. And then we set each of these equal to 0. So 2x plus 1 equals 0. 8x minus 3 equals 0. And in this one, subtract the 1. We get 2x equals negative 1. Divide by 2. We get x equals negative 1/2. Okay, this one, add 3. You get 8x equals 3. Divide by the 8. And you get x equals 3/8. Okay, so again, solution set notation, smaller one first. Well, if you've got a negative and a positive, the negative's first. So negative 1/2 and then 3/8. Bing, bang, boom. Okay, moving on. Like I said, so I told a handful of you, if you're struggling with factoring, you can see this chapter is heavily reliant on factoring. So if factoring is something you're still struggling with, that is your cue to come visit me on a PRT. Okay, clearly factoring is not going away for the next couple chapters. So please, please, please come visit me. Sip of coffee. And away we go. Okay, next one. It is set equal to 0. It is in standard form. Check and check. Okay. No GCF. I've got 1, 2, 3 terms. So I'm actually, yes, this is a box game. I'm going to use the T-chart here. We're multiplying to the 4 times the 15 to get 60. So we're trying to multiply to 60 and add to 17. Well, what two things do that? If you're thinking about the factors of 60, well, 1 and 60 isn't going to do it. 2 and 30, certainly not. 3 and 20, still not there. 4 and 15, we're getting warmer. 5 and 12, now that's the ticket. 5 and 12. Okay, so remember when you do this, that means you keep that first term the same. So 4x squared plus 5x plus 12x. We break that 17x down into our two numbers we just said, plus 15 equals 0. And then we group. So from the first two terms, I'm going to pull out an x. So that's going to leave me with x times 4x plus 5. And then from our next two terms, I'm going to pull out a 3. So plus 3 times 4x plus 5. You'll notice I'm starting to move a little bit quicker because, again, this should be old news, guys. I'm not going to beat a dead horse with factoring. If this is too fast for you and you need to slow down, great. Pause the video, but it's got to not be, okay? If this is going too fast, then that means you got to work on your factoring. This should be quick and easy. This is not a challenging one to factor, okay? Next, we pull out the 4x plus 5, so we get 4x plus 5 times x plus 3 as our leftovers equals 0, which means either 4x plus 5 equals 0 or x plus 3 equals 0. Okay, hopefully you're starting to get pretty good at solving these, right? I'm not going to show both steps in this case. Hopefully you're like, okay, well, we've done a couple like this. In this case, I would subtract the 5 and divide by 4. So it's going to be negative 5 over 4. And in this one, you're just subtracting the 3. So it's going to be x equals negative 3. And there you go. Which one's the smaller number? Well, negative 3, or 3, I guess, is technically a larger number than 5/4, which means it is more negative. So negative 3 is our smaller number, and then negative 5/4. If you're like, what, Mr. Kaplan? Picture a number line. Negative 3 would be further to the left, right? Negative 5/4 is really negative 1.25, so it is not as small as negative 3. And there you go. These last few examples, we're going to be focusing in on, okay, now we've really got to do all 3 steps. Notice none of these are set equal to 0, and that's okay. That is always your first step. Set it equal to 0 and get it in standard form, and then factor. Okay, now these aren't too bad, but you got to set them equal to 0 first. You can't do anything till you do that. So this first one, we got x squared equals negative 10x. Get the stuff on the same side as the x squared. So I'm going to add the 10x to the other side. And notice one's x squared, one's 10x. We can't combine those. Don't add those together. X squared plus 10x is just going to be x squared plus 10x equals, on the other side, you've got 0. Okay, well, how do you factor that? Always look for a GCF first. Oh, look, they both share an x, so we're going to take an x out. And that's going to leave us with x squared divided by x is x, and 10x divided by x is plus 10 equals 0. Well, here we have either x equals 0, right? That's from our GCF. Or x plus 10 equals 0. Well, this one's solved, and this one would give us x equals negative 10. Okay, so negative 10 and 0 are our solutions. One moment, please. Ooh, sorry, everybody. Mrs. Kaplan is leading meetings, so we've got special guest star Theodore here with me now. So if you hear somebody talking about a balloon, chances are it's him. Okay, so let's wrap up our last couple examples here. And away we go. Last two. We've got r squared minus 120 equals 7r. Okay, so again, notice this is not set equal to 0, right? So we got to start by subtracting the 7r. And also imagine, where should the 7r go in this order? Well, r squared minus 120 minus 7r doesn't make a whole lot of sense. Yeah, I'm doing math, bud. It is. You want to factor? He can't factor. He's 1.5. Okay, so r squared minus 7r minus 120. If you're thinking about the order, that's the order it's got to be in. Okay? Then we do our t. We're trying to figure out what two things multiply to negative 120 and add to that negative 7 in the middle. Okay? And this might not be immediately obvious, right? And that's okay. This is a little bit of a tougher one, but I'll just kind of jump to it here for the sake of time. Those two numbers would be negative 8 and 15. Good handwriting, Mr. Kaplan. You're doing great. -8 and 15. There we go. Okay. So that means that this r squared is going to become r squared minus 8r plus 15r minus 120 equals 0. Okay. From the first one, the first two terms, I'm going to pull out an r. Hi, buddy. Yes, you do have a balloon. Okay. And that's going to be with r minus 8. Thank you. And then from the next two terms, we can pull out a 15. So plus 15. And that's going to leave you with r. And then, hey, look, 120 divided by 15. We just talked about this. That's going to be -8. So r minus 8 equals 0. Bud. We get r minus 8 times r plus 15 equals 0. Okay. Last but not least, hopefully you're looking at these. Okay, well, if r minus 8 equals 0 and r plus 15 equals 0, that's going to give me two pretty basic solutions. You're going to have -15 and +8. And there you go. Last but not least, we've got 8b squared equals 2. Again, always start by getting it in standard form. So you're going to subtract the 2 to the other side, set it equal to 0. You get 8b squared minus 2. Again, not like terms. Don't actually subtract the 2 from the 8. So 8b squared minus 2 equals 0. Next, always check for a GCF first. Well, these share a 2. So if I pull out a 2, that's going to be 2 times now 4b squared minus 1 equals 0. Okay. Last but not least, now in this particular case, we actually can keep factoring this. This is our difference. It's subtraction of 2 squared. 4b squared is 2b times 2b. Yes, buddy. And 1 is 1 times 1. Okay, so this is going to factor to 2 times 2b plus 1 times 2b minus 1 equals 0. Okay. Last but not least, that means, so look, this is where your GCFs get a little bit confusing. Not really confusing, but look, the difference here is in this one, you actually had a variable in your GCF. So you said, oh, well, x equals 0. In this case, your GCF is not going to give you a solution because you would just say 2 equals 0. Well, and that's not true. There's no variable to solve for there. So that actually just doesn't give you a solution. So your two solutions are going to come from 2b plus 1 equals 0 and 2b minus 1 equals 0. This one would give you b equals, you'd subtract the 1 and divide by 2, so -1/2. And this one you would add the 1, so +1, and then divide by 2, so +1/2. And there you go, -1/2 and +1/2. And there you have it. Thank you all so much. I apologize. Oh boy, Teddy's typing all sorts of stuff across the notes here. Oh goodness. I apologize for the special little guest star at the end here. But, you know, if the roads are too icy for us to get to school, the roads are too icy for our nanny to get here. So it's going to be a fun day. If you have questions, pop by office hours later. I will be checking to make sure you have the notes taken tomorrow. So please make sure these are all taken down. And then we will do the homework together in class so I can answer some questions, okay? With that, have a great day, everybody. Good mathing, and thank you all so much.